Hello, today we're going to be talking about how to wire a potentiometer for using the correct pinout. First off, I think it's important to start by understanding the pins of a potentiometer. Potentiometers have 3 pins. There's going to be a pin 1, pin 2, and a pin 3, okay? Pin 2, which is the collector, usually connects to something circular like this. And then from pin 1 and 3, there is usually a resistive track that connects them. So here we have a resistive track all here. And then the collector has an arm that comes out and connects to the resistive track. So what you have here is pin 1, pin 2, and pin 3. And pin 1 usually is where your voltage comes in. So your voltage will come in, go up the resistive track until it reaches the collector, come down and out pin 2. What that means is, as you vary the location of this collector, you can have less resistance or more resistance, which inversely means more voltage out or less voltage coming out of pin 2. Okay? We'll keep that in mind and use that to help us understand how to wire a potentiometer. Typically, we find potentiometers are wired in one of 2 ways. One, let's suppose you were using a potentiometer to vary the resistance to dim an LED, okay? Let's start by saying that you've got your voltage coming in here, okay? And your voltage is gonna come out and it's gonna hit that potentiometer. Okay? From there, you'd have your collector that's going to hit somewhere in the middle of that, and it's going to come over to your LED. This is an LED. Okay? And from there, it's just going to come and return back to your source here. So what happens here is, as you vary this resistance, your LED is going to dim or brighten, okay? If we look at this and compare it to our potentiometer here, we're gonna recognize that this is pin 1, this is pin 2, and this is pin 3, okay? You'll notice that pin 3 is just kind of hanging out there. This is a situation where you're only going to measure the 2 pins. Now you might want to add another resistor in here so you don't destroy your LED or something like that. But as far as the potentiometer goes, you can wire it up this way and leave pin 3 just hanging. Now a lot of people will take this and they will actually tie pin 3 and pin 2 together. And what that does is absolutely nothing different. It will still measure the same. It'll still take the path of least resistance, but it does clean up your schematic and you're not leaving a pin hanging. And a lot of people prefer that, okay? The other way, and probably the more common way that we see people wiring up potentiometers, is using them in a voltage divide situation. Now a voltage divide will take a voltage in, run it through some resistors, a couple of resistors, and get a percentage of that voltage out on the other side. The equation is this: your voltage out is equal to your voltage in multiplied by resistor 2, which is usually the unknown resistor, divided by resistor 1 plus resistor 2, okay? And we'll use this now to show you how that wires into a potentiometer. Let's suppose you have your voltage coming in, similar to last time. And we're going to have this voltage come in, and we're going to do our potentiometer this direction this time. Okay? And we'll have this coming back. And you want to measure a voltage that's coming out the other side. So, Vn. And on this side, we're going to have a this is your V out. Okay. What we have here with the potentiometer is, you see there's only one resistor, but where the collector is connecting divides that resistor into two. Okay, so what you end up having here is R1 and R2. Okay, and when this collector is all the way up here, R1 would go all the way to 0. When the collector is all the way down, R2 would go all the way to 0. In either of those scenarios, if it's all the way to the top, R2 is the whole resistor. And if it goes to the bottom, R1 is the whole resistor. But the whole resistor never changes. The whole resistor has the same value regardless of where the collector is. So here, if we go all the way to the top, R1 goes to 0, R2 and R2 are equal to each other, so this is just 1. So if the collector is all the way at the top, your voltage in becomes your voltage out. Basically, you're not hitting the resistor at all, you're just shorting straight to the voltage out. If the collector went all the way to the bottom, then R2 would go to 0. And when R2 goes to 0, then this whole part of the function becomes 0, which means your voltage in times 0 is 0. So if you put this all the way to the bottom, you get no voltage coming out. The voltage just returns. It's just grounded out, basically. If the collector is right in the middle, so R1 and R2 are equal, then you basically end up with 1 over 2. You get 1/2. Your voltage out will be half of your voltage in. So this is how you would do a voltage divide with a potentiometer. And to make sure it's very clear on our pins, you still have the same pins. Pin 1 taking your voltage in, pin 2 with your collector, and pin 3 coming out the other side. So when you were wiring your potentiometer, these are the two main types of pinning scenarios or wiring that you would encounter, and here's how you would handle that. Thank you very much.